Let us start this video by trying to analyze how we as users generally use computers or laptops in our day-to-day lives. So one common manner in which we interact with our laptops or computers is that we see a desktop on the screen, which has several different icons or options that enables us to interact with different functionalities that the computer has to offer, including handling the files, like creating new files or moving files between folders, storing your photos. Then there are other applications like browsing the web and so on. So basically, if you think of the Windows operating system, Windows is a UI or front-end based operating system. That is, the users interact with the Windows OS generally via the graphical user interface. Another way to interact with the operating systems is via the command line interface. For example, in Windows, if you have seen the CMD application, that is the command line prompt, that is one way that the users can directly issue command-based instructions on what are the operations that they want the computer or the operating system to perform. Let's take another example of Linux. So Linux basically has something called a terminal. Terminal is also a command line prompt in the sense that the users can interact with the computer to perform various set of operations. But if we come to think of it, all of this is still on a very high level in the sense that we as users just see that, okay, with some clicks on the GUI or via some basic commands on the CLI, we are able to achieve a variety of operations on the computer. But let's also think how these operations are actually happening. For example, as simple as trying to open a file would require, first of all, identifying where this file is stored in the disk, then reading from there, and then displaying it on the screen. All of this is actually provisioned by the operating system, which acts as an interface between the user or the user applications and the hardware like CPU, memory, or IO devices. Let me actually take some more examples to explain this better. Let's say we are using a GUI based operating system like Windows or Mac OS. And let's just use the same example of opening the file that I just mentioned. Now, if we as users want to open a file, we will first go to the location of that file by clicking on various directories or folders via the GUI. Once we have identified the file that we want to open, what happens is that we try to open it, let's say by double clicking the file. So the operation that we are performing here is opening a file. And like I said, the kind of operation that it entails is get file path, then find file location on disk, and then read and display the file on GUI. Let's just keep note of the kind of operations that the simple double click that the user performed on the GUI translates to behind the scenes. Let me also take an example of a CLI based operation. So let's say we are using the Linux terminal and we want to copy a file. Okay, so if you are aware, there is a command called cp that helps to copy a source file, let's call it source.txt, to a target file. Let's call the target file as target.txt. So the cp is a command that the Linux terminal provides us with. Again, let's try to understand what is happening behind the scenes whenever this command is executed. So first of all, it would be required to open both files. Then the overall operation that needs to happen is that we need to copy the text of the source file as it is to the target file. And for that, there would need to be some sort of a memory buffer, and we would read the source file chunk by chunk, store each chunk one by one to this buffer, and then one by one write each of the chunks to the target.txt file. This will be followed by closing both files. So again, let us note that while the user only executed this cp command or the copy command, the actual set of instructions or the actual set of operations that happen behind the scene are actually very seamless and hidden from the user. Let me also take a third example of a very simple C program. The job of this program is to say print hello to the screen. Now, once this C program has been written, the next step would be to compile the C program. The C compiler already knows what are the exact instructions that it needs to perform so that hello gets printed onto the monitor. This detail is basically abstracted from us. We as users just add this print command to the C code, but then this actually behind the scene gets converted to some different set of instructions that are abstracted away from us. But then these are the instructions that help print hello to the monitor. The common denominator that we observed in all of these GUI, be it CLI or the basic C program that I discussed, is that there are some set of instructions that are always abstracted away from us and that get executed in a very quick and seamless manner. And all of this is actually the job of the operating system. In each of these examples, in the first example, when opening the file, we were interacting with hardware like the disk. While copying a file, again, we were interacting with hardware like disk. And then when printing hello to the screen via a C program, we were again interacting with hardware like a monitor. As we discussed in the previous video, users in general do not directly interact with the hardware. That is the job of the operating system. Therefore, operating system is an interface between user or user applications as well as the hardware. Let's try to analyze this diagrammatically. So there is user and then there is the computer hardware. Like I said, operating system acts as an interface between user and the hardware. So this interface is going to be the OS or the operating system. Let's try to understand what are the different parts of this operating system. So the parts that the user directly interacts with are, say, the GUI or the CLI. And then there is a set of different functions that the operating system is responsible for. Let us try to list down all of these functions as well one by one. So the operating system is going to be responsible for process management. Then it is going to be responsible for IO or input-output handling. This means handling the input-output devices like printer, keyboard, mouse, tablet, monitor, and so on. Then It is also responsible for file handling or file operations, similar to the ones that we discussed in the example before, like opening a file, reading or writing a file, closing the file, right? The operating system is also responsible for communication. One of the examples of communication over here is inter-process communication or IPC. We will go into deeper details about this in our later videos. Operating system is further responsible for resource allocation. A very important part of the operating system is error handling and error recovery. And lastly, security or protection is also one of the pillars of the operating system. There is one more layer that is actually missing here still. So if you see, the point of interaction for the user is GUI or CLI, and then there is a set of all of these different set of operations or responsibilities that the operating system has. But then how does this GUI or the CLI actually make use of all these different set of responsibilities? This is made possible via something called system calls. System calls. So what is a system call? A system call is basically a set of different methods or functions that can be called based on what you want the operating system to do. For example, let's say for file operations, if you want to open a file, there is a system call called open. This is actually a function. This takes certain parameters as well. We don't need to go into that level of detail at this point. At this point, we just need to understand that system calls are basically a set of functions that enable the GUI or the CLI to interact with the different functionalities that the operating system performs. Let's actually go back and see this and try to analyze what kind of system calls would be required in each of these scenarios. So to open a file, the system call, like I said, that is used is called open. This takes the path of the file. The next system call that will be involved over here is to read the file. These are, by the way, actual system calls that are available in Linux operating system. There are parallel similar system calls that are available in Windows as well, just that they are available under different names. And then let's say the user wants to even close the file, then the system call for that is called as close. We will discuss the types of these system calls in detail in the next video. Then in this example, when we are trying to copy a source file to a target file, again, the system calls that would be involved would be first of all to open both the files in memory. Then the read system call to read from the source.txt file. Then the write system call to write to the target.txt file. And lastly, again, the close system call to close both the files. And again, very similarly, you can by now guess that the printf method would require the write system call to be executed at the OS level. In the next video, we will further discuss the types and working of these system calls in greater detail. So see you in the next one.